All right. Okay. So are you ready? Because I'm ready now. Oh, and you turned off one light. Thank you so much. Um, okay. So my talk is about decentralized applications with Angular and Embark, and you might be wondering what this is about. And I think it's going to be interesting. The reason I'm going to talk about this is because I started actually a new journey myself, like a few months ago. Like a new job in the blockchain and decentralization space, and I thought it might be cool to share some ideas and inspiration, how you can actually build apps with Angular that are decentralized themselves using a tool called Embark, which is a tool that I'm actually working on these days. And so this also means that the talk is a little bit less focused on Angular, so there's going to be Angular in it. It's just going to be probably less than in all of the other talks. The reason for that is I have 30 minutes to cover decentralization, blockchain, smart contracts, and Embark. Ha ha. This is going to be challenging. So let's just start. Right away. What is a decentralized app, anyways? I just want to make clear that there's obviously different definitions and different interpretations, depending on whom you're asking. But a very general definition for that would be that a decentralized application is an application that does not run on a single computer. I guess that's pretty easy to understand, right? It's an application that doesn't run on a single computer. By the way, we also call decentralized applications dApps, or some people call them dApps. So whenever I say dApp, this is on purpose, and that's what I mean. To visualize this a little bit, we have three different network topologies here: centralized, decentralized, distributed. I guess the idea is relatively clear. When you look at the centralized graphic there, you see that all the nodes are connecting to a central place and probably retrieve or receive information from there. Whereas in the decentralized graphic we have multiple places from where the nodes can actually receive data or even talk to. Whatever this means, this is very abstract, right? But this could be a network of computers that are talking to each other, obviously. Another one is the distributed network topology here, where you can see that everybody is actually connecting to everybody in some way, right? It's like a peer-to-peer network. I guess what is good here is if we end up with something that is a mix of these last two, like decentralized and distributed, because the reason we want to have this is that when we build apps and when we use apps as users, we want to have some benefits, which are, first of all, decentralized applications tend to be faster. Obviously, again, this depends on what you're building, but in general, we could think of things like, just simply sending and receiving data, except instead of receiving data from just a single place out there in the internet, you could receive data from different nodes at the same time and bits from them. There's software out there that does that already, right? It's more reliable. There's no single point of failure, which means, if like one server goes down, it's not that the whole service goes down. Who has worked with GitHub these days and had a day where, you were just sitting around for a few minutes because GitHub was down? Huh? Yeah, sure, yeah, everyone kind of did that, right? With a system like this would not really be possible, or maybe possible, but the chances would be very, very low because we would have different endpoints that we could talk to. And another important point, probably one of the most important ones, is that the network itself is run by the network. So there's no single authority that controls it. There's no single authority that can actually decide to shut down the whole thing, right? It's a very, very important thing to keep in mind. And I guess this is also more or less the focus of what we're going to talk about today, especially when we enter the space of blockchain. It's really, really important to understand that and to realize what it means to us when we're building apps and when we're using the web as we know it today. So how do we build decentralized applications? Again, this totally depends on what kind of app you want to build. But if we look at how we build apps today, usually we have some sort of services that we talk to, right? Like some web services, we have some sort of computation going on there, servers that we just talked to that perform some certain actions. There's databases that we talk to. There's cloud functions that maybe talk to us even. Then we have some sort of assets that we ship to the users, right? In Angular applications or web applications in general, it's usually HTML and CSS and JavaScripts. This stuff usually comes from a static web server or CDN. And then last but not least, obviously, we have the browser where the user, sees everything. If we would turn that idea into a decentralized architecture in a very abstract way, right? Again, this is blending out all the specifics. We could say that for computation and all the rest, we could use something like blockchain, and we will actually learn in a minute what a blockchain is and how it enables decentralized applications. And then we could use something like a decentralized storage to serve our assets, which is also something that already exists today. There's software efforts going on, open source projects like IPFS, Interplanetary File System, that basically enable us to, similar like BitTorrent, to receive data from different nodes at the same time. One thing I want to point out here, computation, in this particular case, if it is a blockchain, this is not about putting all of our computation on the blockchain. There's reasons for why this is not a good idea. The computation that I'm talking about here really is more the computation that is needed to keep the blockchain running. So what is a blockchain anyways, right? Let's talk about that. Again, I only have half an hour for the whole thing, so I try to give you an overview and a kind of like an interactive demo to demonstrate how this works. So I hope that when you go home today, you at least have a little bit of an idea what a blockchain is and what it can do. So in general, a blockchain is a public distributed ledger that records transactions in a verifiable and permanent way. All right? Okay, we'll just let this sink in for a moment. Distributed ledger, public, and it records transactions in a verifiable and permanent way. I like to say it's kind of like a semi-automated Git repository on steroids that cannot be rebased. Who's using Git here? Like many people, I guess, yeah. So when you use Git and when you have an understanding of how Git works, when you make commits and you have your repositories and you kind of like record your changes and you more or less set them in stone, you can rebase them, right? So you can change them, but you don't do it all the time. This is kind of like you're halfway there to kind of understanding or getting an idea, a basic idea of what a blockchain is. Let's quickly talk about, before we look into what a blockchain looks like, what does it exist? Like, what problems does it solve in the first place? So, and the problems that I want to talk about here really quick is, I call it legacy world problems. They're basically the problems that we have today. They're more or less obvious. We have them right in front of us. We experience them every day, but we don't feel them really if we're not mindful about it. So it all boils down to single authority control. Things like, for example, when you go to your bank and you want to make a money transfer to a friend in a different country, usually there's a lot of work involved to get your money sent to that other destination, right? So it takes a long time until your money arrives. This is because banks have something called a ledger, which is basically just a book in which they write in their transactions. So they record that you're saying, hey, me, Pascal, wants to send some money to that particular person, right? This is like, it needs to be somehow verified in some way. So they write it down. They have to sync that with other banks. It goes through some other entities in the chain to actually end up somewhere. And probably they even charge you a lot of money on top of that so that they actually send the money over, right? Like something like that. So they control fees and everything like that. It's very, it's not transparent, and it can take a long time. As a matter of fact, everything we buy today, when we buy something online, has to go through a bank or a credit card company. And again, they control whether you pay fees or not, how much you pay. And if everything depends on that, that's actually a problem, because if banks decide to do certain things, they can just do it because they control it. But it's not just banks. It's also other things like governments and law systems, right? There's countries on this planet that have a very corrupt government and law systems. We can actually take something like a blockchain and use that to implement distributed voting systems that are completely controlled by the people who run the network. So it's controlled by the network and not by a single authority that decides whether or not somebody should be even allowed to vote or not, right? And this has happened recently as well. Big problems that we have. So in the blockchain world, like when we're imagining we have the blockchain, and the idea of it is that instead of having, if we come back to the bank example, instead of having a single ledger, let's just say that all users of the network will actually have the ledger, the records of all of the records of all of the transactions. So everybody can see everything, and everybody syncs their ledgers with everybody. Completely digital, obviously on a peer-to-peer network. Now, this has the upside that it's a peer-to-peer network, so you should be able to just send money to somebody somewhere on this planet. It shouldn't take weeks or days. It should just take, ideally, a few minutes, if at all, ideally a few seconds. The problem with that, though, is that once we go down that path, that means everybody can see everybody's transactions. So we need to have this in an anonymous way. It should be transparent, but nobody should, unveil their personal data, whatever. You want to keep these things anonymous. This is actually a feature of the blockchain where everybody can see all the transactions, but you actually don't know who is who, right? You only see some hash addresses where some value has been sent to a different address, and that's all you can see. So it's transparent, you can verify it, but you actually don't really know who it was, which is great because you can trust it without trusting anybody. There's consensus rules, which is pretty important because as soon as you enter a peer-to-peer network where something like this happens, where we have a ledger that is shared with everybody, everybody's having the same copy, one node in the network could decide to just rewrite it and say, okay, I give myself, a couple $100 if I want to. So we need a system that ensures that a peer in the network cannot actually alter the data that has been recorded. Right? So there's a certain mechanism that ensures that this is not possible, that this is not happening. It's called mining. We talk about it in a second. And then there's consensus rules that make sure that the network actually communicates and decides and verifies, hey, this particular peer has the correct transactions recorded or not. And on top of that, it's immutable. Just like a Git repository, when you make commits, right, you just add them on top of each other. Let's just forget for a moment that you could rebase everything and everything's gone. And the same thing is the blockchain as well. You only add transactions, it's append only. So whatever you put on there once is there forever, as long as the network runs. Okay, let's talk about blockchain and what is it, how does it work? For that, we need to understand hashes. Who knows what a hash is? A hash function. Okay, cool, that's a lot of people. Then I keep make it very quick. So here we see a hash down there. And a hash function is a function that takes some input and returns a hash of that input. It's very interesting because the output, the hash, is always the same length. So what you see down there is actually the hash of whatever is data, and data right now is an empty string. If I type in hi, you see that the hash changes dramatically. Another interesting characteristic here is that you cannot actually see, looking at the hash, what the data was, right? This is a very important thing to realize. Also, this is one way, so you cannot actually recompute where, like what the original input was. You can only say, okay, this is like a one-way function. Another thing that's important, even if you change the input just slightly, so I remove one letter, the hash changes to something completely different. And it doesn't matter, I can write a book in here. It's always the same length, but the hash always looks completely different. Why is this interesting? Well, it's actually a very important feature here that we're talking about. It's cryptographic proof that if I type in hello world, and I send you this message, hello world, and I give you this hash, you can actually create a hash of this message yourself, and you can verify whether the data that I sent you was really that data that you see or not, if that makes sense, right? You take this message, you take my hash, you create a hash yourself, and you compare those hashes. If the hash is different, then you know the data that you received has been tampered with, right? Very important. It's the same thing that happens in Git, by the way, when you create commits and you see the hashes. This is all a hash created based on your code changes. Anyways, this is the first building block. The next thing is a block of the blockchain. Let's understand what a block is. So what we see here is exactly the same thing. We have our hash down there, we have data, and then we have a block number and something called a nonce. Now, one thing to realize here is that the hash down there has a very interesting property, which is it starts with 4 zeros here, right? Now, let's just say, we just make a rule up. We just say that we say this block is valid when the hash that is in there, depending on whatever data is in there, starts with at least 4 zeros, right? You see that when I change the data, if I say like hello here, the hash all of a sudden doesn't have 4 zeros anymore. So the rule is broken. We say this block is not valid anymore, right? Now, in order to figure out what is the hash, like how do I get to a hash that has at least 4 zeros, you can now go ahead and use this nonce here and change it manually, right? You can type in 1. Okay, no, that doesn't do it. 2, also not. 3, also not. I can do this forever until I find the number that actually generates a hash with the data that starts with at least 4 zeros. Does that make sense? That takes a lot of time, but computers are good at this. And this is what mining is all about, right? So we can actually tell the computer, hey, find the nonce that will actually generate a hash that starts with at least 4 zeros. And this rule, at least 4 zeros, is just something that we decided at this point, right? So I click mine here. This is going to do some work. And now found a nonce that matches. And now I can say this block is valid. This is just something that I defined. Now, the important point here to realize is that mining is basically the process of solving a math-intensive puzzle, right? In order to verify whether a block is valid or not. Now, what is a blockchain? We can take this and say, okay, we create a chain out of these blocks here. So here we have 5 of them. And it's exactly the same thing. The only thing that is different now is that every block actually points to the previous block. So we have a pref hash down here. We see a 000 1578, and the same one is the hash from the previous block. Which means if we take this whole chain and we actually go ahead and change the data that is in this chain here, we see that these 2 blocks now are invalid. Why? Because we just changed the hash and it doesn't actually match the rules anymore. It's invalid at this point. And not only this one, also the following one, but every block that was before that is still fine. That means in order to get the whole chain valid again, we need to mine the block again from here. So we have to remine this one and we have to remine this one. And now they're all green again. Now, why is this important? Again, this is a blockchain. The data is actually a set of transactions. So this is exactly the same thing now that the data is not just some arbitrary data, it's actually transactions. This is our ledger. This is the book in which we record, you send this amount of data to this person. Just that there's no concept of person, there's only the concept of an address that we don't see here right now. I hope that makes sense. So it basically means that I cannot just go ahead back in time and change some transactions without making the whole chain invalid. Okay, but how do we now actually ensure that the whole network doesn't allow me to actually change this? Like, I can still go ahead and change this now and just remine all the blocks and I'm done. Well, this is the power of this is where the peer-to-peer network comes into play. So here we actually see we have the same chain 3 times. We have peer A, B, and C. Right? They all have exactly the same blocks, the same hash. When I go ahead and I make a tiny change here, those 2 blocks are invalid, while 2 other peers have a chain that end with a hash that are the same. So there's basically a simple democracy going on here where they say, okay, the majority of the network agrees that this is the right hash, but you have a different one, so you're not accepted. Does that make sense? Yeah? This is the consensus rule in this case. Now, depending on with which blockchain you're dealing with, the rules might be different, the exact rules might be different, but it's really just about the concept that you get an idea, okay, we have this data structure that can actually not be tampered with because the whole network agrees that it has to have a certain value. All right, so now that we have an understanding of that, let's talk about some use cases. So it turns actually out that if you know Bitcoin, if you heard about Bitcoin, this is actually powered by something like that, right? Bitcoin is a blockchain. There's other blockchains. There's not just one blockchain. There's also Ethereum and many other projects that actually try to solve this problem in a good way. And it turns out that if you go beyond this, if you go beyond just thinking about making transactions of simple values, like digital money, you can actually implement things like identities. Like you can put your identity on the blockchain. You can verify with a hash that you are you. Instead of having a passport in your pocket, you could have that digitized on the chain, and you can have a hash that would verify that you are actually the person that you're saying that you are. There's actually a project happening right now that does that. It's called Uport, which is solving that. There's other use cases like governance and democracy. Organization called Aragon is working on that, and they've been very successful with that. If you work with decentralized storage systems where everyone here in the room would basically offer their machines as storage for everybody in the world, you need an incentive to do that. Why would you do that? Why would you offer your machine as a storage for a network? There's a project called Filecoin, which would actually make you earn money by offering your machine to the network. So this is really about giving power back to everybody who actually participates in the network, instead of having a single entity that controls it. And there's even Airbnb equivalents that make that happen, CryptoCrypts and other projects. But how do you do that? How do you actually go beyond just transferring digital money, digital value? Some blockchains, like the Ethereum blockchain, which is the one that we're talking about, has the concept of smart contracts. The name is very misleading. It's really just simple programs, and they look very similar to JavaScript, if you will. Forget the name contract for a second, really. A smart contract is really just a program that lives on the blockchain. So you can write a contract, a program. You can actually deploy it on the chain, and other people can use it. They can actually call this program that you've just deployed. It's very similar, like when you interact with a blockchain, when you send transactions, you need an account. And an account is really just a public-private key pair, right? That's your wallet, essentially. Whenever you hear about a digital wallet, it's actually just a pair of public and private keys. If you own the private key, you own whatever value is available on that address that this private-public key pair resolves to. And the smart contract is very similar. It's also like an account. Like from your perspective, it actually doesn't make really a difference. It's just that it's controlled by code. It's bytecode that's deployed on the chain. It holds a certain balance. It holds storages, like a storage where you can actually save value. This is where it actually enables you to implement systems on top of this distributed network, which is very powerful, and the bytecode itself. So here's what it looks like. You would have some smart contract source. We see in a few minutes actual code. You compile it, you get bytecode out of that, you deploy that to the chain. That's when you create an instance of that contract. But what you also get from the compiler is something called an ABI, an application binary interface. This is more or less something like a JSON structure that you can use in a web app to actually create an equivalent contract instance in your JavaScript app, for example, and use that to talk to that smart contract instance on the chain. The cool thing about this is that you can actually put logic on the network without, with people trusting you that this program is going to stay the same because you can't change it anymore. It's written in stone. Has upsides and downsides. If you want to make changes, you have to redeploy a new contract. But there's architectural patterns that work around that. So let's make a contract called a lottery contract. The idea is very simple. We have a smart contract instance on the chain which has a price pool. You see Ether here. Ether is a currency, the currency of the Ethereum blockchain. Again, this talk is about Ethereum. You can basically send Ether to that contract. So we have two players. One player sends Ether, one Ether in the price pool. Player two sends some Ether in the price pool. And then there's a manager, that's the owner of the contract, who deployed it. He can actually pick a winner. So it's really just a randomizer that would pick a winner and assign the value back to any of those players. The contract itself isn't really demonstrating the real power of what you can do with it, but this is really more about you giving an idea, how do you actually do it, right? Okay, so let's take a look at some code. You write smart contracts in different languages. The one that is mostly used right now in the Ethereum world is Solidity. And again, it looks very similar to JavaScript. So you have contract, lottery. Contract is like class. So you can imagine this is just a class, right? So you have a class where we define some addresses. We have the manager, that's the person who actually deploys the contract. We have public players, that's an array just with the players that are entering the lottery. We can have events. In this case, we create 2 events, one for when a new player has entered the game and when a winner has been picked. And then you can have constructors to set data. There's the enter method that actually lets people enter the game. And then we have a randomizer, this is a pseudo-random. And then we have like a pick winner function that can only be called actually by the manager. So here you see a construct that's specific to this language, a require statement which says, okay, the sender of the transaction that comes in has to be the manager. All right, so this just gives you like a rough idea what a smart contract looks like. But let's actually see, how do we talk to this? Assuming that we take this contract and we deploy it to the blockchain, how do we build an app that actually talks to this contract and does something with it? This is where a library called Web3 comes into play. There's other libraries as well, but this is probably the mostly used one. Web3 is also like some term that describes the decentralized web, the new web. It's a JavaScript RPC client, so you basically send RPC requests to the network that you're connecting to. It gives you access to your accounts, to your wallet, your digital wallet that you have created, that you own and nobody else. You send transactions with it. You can create contract instances in the JavaScript world, right? So an equivalent to what you've already deployed to the chain, you can create like JavaScript objects so that you can actually work with the thing on the chain. And it has utilities and other things. And I'll just like to give you some vanilla example. The way this looks like is that you would use the library to create a new instance of it. A provider here is a wallet that you can create. Again, just a private public key pair in this case. You can have methods like get accounts where you can tell Web3, hey, give me all of the accounts that are associated to my wallet. Right? And then you can work with that. By the way, there's an await statement here in case you're not familiar with async await. It basically means that get accounts returns a promise. And we're using a different syntax for that. So most of the Web3 APIs are promise-based. Here we see how we create a contract instance. What we do here is we create a new contract with the Web3 library using the API that we've created earlier with the Solidity compiler and the address of the smart contract when it has been deployed. Right? When you deploy a smart contract instance, you actually get an address back, and you can use that to create a JavaScript object that would talk to that. If you would want to enter the lottery, you can call methods like this, your contract.methods.someMethod, and then you either have send or you have call, depending on whether you just want to call a method that makes you receive data, or whether you want to call a method that makes you actually execute code on the chain. Because if you do that, it actually costs you money. It's called gas in Ethereum land. So when you cause a transaction, you have to pay for it. In Angular, this could look like this, right? So we have a provider, and we would say, okay, we create a new provider for the Web3 library so that we can actually ask for it in DI. We could create a new lottery object that would be injectable using a factory provider as well. This is really just the code that we've just seen wrapped into Angular-specific syntaxes, if that makes sense. And then in an application, we could just go ahead and ask for the lottery instance that we've created for Web3 as well, and then we can just implement methods like this. This is the equivalent pick winner method that our contract has on the chain, right? And you see here, it's really just getting the accounts that your wallet has and telling your application to pick a winner with this account, which in this case has to be the manager of the owner of the smart contract. Okay, how do we put this all together? Tooling in this space is very rough because it's all like pretty new. We're still building these things. And that's where Embark comes into play. Embark, as I mentioned, is a tool that makes developing decentralized applications on top of the blockchain, but you don't have to, as easy as possible. At least that's what we're aiming for. It comes with a couple of features. Like first of all, it's a CLI. So it's a CLI tool that takes care of spinning up a node, like a blockchain node for you that you can deploy your contracts to, and you can talk to them locally until you eventually decide to actually connect to a main network, and deploy to production, if you will. It manages and tracks your smart contracts, and it compiles them as well. So it's like a CLI scaffolder that takes care of taking your smart contract source, compiling it, managing the ABI that's created. It creates some equivalent JavaScript code for you that you can use in your application. So it's pretty convenient. And on top of that, just recently we actually released a web interface that gives you even more things like an explorer, a block explorer that lets you browse through the blocks that are being mined in real time, and you can debug your smart contracts from there. We call it Cockpit, and actually maybe I have a second to show that. So let's see it in action. Let's just actually do that. So here's my terminal, and I'm in this lottery project. I'm not going to go through the source, but just that you get an idea here. We basically have just an app. This is where the JavaScript source is in. We have a contracts folder. That's where the contract source is in. And then, this is like a typical Embark app. Now, you might think, wait a second, I'm an Angular developer. I actually want to use my Angular CLI because I'm used to it, and it has the great building capabilities. And we totally agree. And we're still discussing and figuring out how can we make Embark integrate well with something like Angular CLI or Vue CLI or whatever library you happen to use. At this point, Embark also comes with its own build pipeline. So I'm in this project. I'm just simply going to start it. So I'm going to say Embark Run. And by default, it's also going to spin up a browser instance. I'm going to tell it to not do that. And this is what it looks like. Now, what's happening here is a lot of things. First of all, Embark is going to spin up a blockchain node for us. It's going to spin up an IPFS node for us, which is the decentralized storage thing that I talked about earlier, whether we use it or not, but we can disable and enable it. And then what it does, it compiles all of our smart contracts, and it deploys them, and you can actually keep track of that in the logs over there. So all of your smart contracts will be listed down there. You can also see like live logs that are coming down here from Embark itself. It spins up a web server for your application, and then you can, you have an interactive console down here. So now what I'm going to do is I'm going to open up this application. The port is a little bit weird. First of all, I'm opening my wallet here. This is a browser extension called MetaMask. You can basically take your private key wallet and import it there and make that connect to a particular network. Right now it's connected to the main network, but I want to connect it now to my local network that I've just instantiated with Embark. So for that, I'm going to click on localhost here. It connects to that one, great. And you also see that now all of a sudden I have an account here that has a lot of ether. That's like development account, right? It's not really real money in this case. And we have a couple more here. We can actually create infinite accounts and change and switch them. Okay, so let's open this up. So this is port 58804. So localhost 588 again 04. Anything else? No, that was it. Hopefully, I hope it works. Yay! So this is our application. It's super simple. The contrast is a bit bad, but you see what it's about. We have a price pool, 0 ether in there. Now what I can do is I can say, okay, I want to enter the lottery. So I'm going to enter 2 ether. Let's just check really quick. We have right now 22 ether in here, which is quite a lot. So I'm going to enter it. I hope it works. You see it pops up, and it actually asks me to confirm this transaction. That's very important. You control which like when and if you want to transact something. So I'm going to do that. I confirm the transaction, and now there's 2 ether in there. Even though I deployed the contract, I cannot undo this, right? Let's change the account, and let's just be somebody else, account number 3, for example, and enter a different amount, like 5 or so. Let's do that. Same thing, we confirm that. This is a transaction that has to be mined, right? That's what we've seen earlier. It happens very fast here because this is a local node. Okay, and now I can go ahead and say, okay, let's actually pick a winner. So I go back to the account number 1. I'm allowed to pick a winner, so I do that. Again, it's a transaction that I have to confirm, and I do that. And you see it resets to 0, and let's double check whether the 5 Ether or 7 or whatever we had in there, oh, they actually went back to account number 1. Okay, so it has worked. That's great. I know I'm pretty much out of time, so I'm just quickly going to give you a quick peek of Cockpit, the web interface. So this one is going to be hosted on your same application /Embark, and then you can open it up with a token. This is what it looks like. And as I said, it basically gives you a web interface into your own node and your current Embark instance. So you see which services you are connected to, like Ethereum. We have IPFS running. We have a Whisper node running, which is another protocol that I didn't actually talk about. We see the live logs here. We can use the Explorer to actually see what accounts are connected. We see all the blocks that are being mined, and you see in real time these blocks are being mined right now on my node, right? And all transactions, and you can look into your contracts that you have deployed. You can click into those. You can actually interact with them as they're live on the mainnet. Anyways, I think this is pretty exciting. So yeah, I hope this talk gave you a little bit of an idea what this blockchain thing is and how you can build applications that sit on top of it. Maybe maybe you're going to build something yourself. If you want to talk about this with me, catch me after the talk here. So thank you so much for listening.
Thank you very much.